All right. So we've been dealing with absolute values this entire lesson. And this is just to give you a sense of like what an absolute value graph looks like. And you guys have probably already seen it before, but if you haven't, so on the left, we just have y equals x. So it's just a straight line. Now, what we know about absolute values is they can never be negative. So any of those negative values that are down here on our line are then flipped up above the x-axis. So we end up with our absolute value parent graph over there. Okay? So this is just a little exploration. And a lot of the problems that we go through are going to be based on this. So make sure you understand the way that all of these things work. So this first one, when we have a negative, think of if you plugged in a positive number. So if we plugged in a positive or a negative number, we would get a positive value for absolute values. However, since that negative is on the outside, that means that our entire graph is going to be flipped upside down. So for A, we're going to end up with something that looks like this. And for each of these, I'm just going to give you like a rough overview of what they're doing because they go through a whole bunch of different transformations. And then we will kind of go off of that. So for B, any value that we have is being multiplied by a half afterwards. So that's what's called a vertical compression. And in a vertical compression, so normally for this one, I'll draw like the normal, or I'll try to draw the normal absolute value graph. And then a vertical compression would just mean that it's like half the height. Okay, so it's kind of flattened. It's flattened by a factor of a half. And then moving on to C. And you could plug in values if you wanted to, and you could do this, but I'm just giving you guys a little shortcut. So if we have a minus and it's inside a parenthesis or within the function, this minus is going to move it to the right how many ever units that they give us. So the graph itself is just the same absolute value function, but it's going to start over here at 4. And I know it's kind of backwards of what you guys would think. So there will be one half of it, and then I think, yeah, there's the other half getting close to the edge. So it's the opposite of what you would think. You would think -4 would move it to the left, but it's the opposite. And the reason for that is I have to plug in a +4 in order to get back to 0. Okay? So if I have to plug in a 4 so that I have 4 minus 4, and then I get a y equals 0. So that's why that moves over to the right. So then vice versa, we have this +4. So that's going to move it to the left. 1, 2, 3, 4. And again, it's just going to be a normal absolute value graph, but it moves to the left. And then these E and F act just as you guys would kind of think they would. That's just kind of like a y-intercept, or the same thing of like y equals mx plus b. So that's going to be, this one is -4, 1, 2, 3, 4. That's going to go down. So that one's pretty normal. And then we have our V-shaped graph. And then for F, that's +4. So that's going to be up here. Okay? And then just one more problem here, looking at chemistry. So for hydrogen to be a liquid, it must be within 2 degrees of 257 degrees Celsius. Write an absolute value equation to determine the least and greatest temperatures at which hydrogen will remain a liquid. Solve the equation. So we're just going to call T is our temperature. Now, think of this for a second. So the value has to be in between a range of 2. So we already know that it would be like negative 255 and negative 259 would be our two values. So the way that we're going to end up setting this up is we're going to have the absolute value of t minus our negative 257 degrees. I don't have to put that in the problem. Will be less than or equal to 2. So that's going to be a plus. Now, I actually don't need that absolute value. I think that's just an equal sign. So I'm going to drop the bars and I'm going to say t plus 257 equals 2 and t plus 257 equals negative 2. So I subtract 257 from both sides, and here I get negative 255, and here I get t is minus 257, and I get t is negative 259. Okay, so those are our two values right there that I have to fall between. So if I was going to graph that, I would just graph points. So we have to be between this guy and this guy in order to be a liquid. Okay? Hope you guys have a great day. See you tomorrow.